Hey everyone, this is the 2018 exam, still free response section, no calculator. This is a question that you have seen a lot of similar questions to. So number 4 is giving us the height of a tree at time t is given by a twice differentiable function h, where h is measured in meters and t is measured in years. Selected values of h of t are given in the table above. So the height of the tree, I guess I'll ask you, the height of the tree is which function? The h of t function, and then we also have time in that chart. So we have time in years, and then we have h of t, which is the height of the tree being measured in meters. I'm going to write height. Use the data in the table to estimate h prime of 6, and then using correct units, interpret the meaning of h prime of 6 in the context of the problem. So the first thing you're doing is figuring out how to estimate h prime of 6. And you want to just think about, what are you doing here? How are you going to get that number? So you would be looking, since you're looking at time 6, you would be looking at these numbers here that I'm highlighting, and the derivative is the rate of change, right? The instantaneous rate of change, which you can also get with slope. So they always say estimate, because an instantaneous rate of change would just be the slope or the rate of change at one point. And that's not what you're getting, but you're going to get approximation for it by getting the average rate of change between times 5 and 7. So the first point is going to come from you just finding the slope between time 5 and 7. So it'd be 11 minus 6 and 7 minus 5. And that would give you 5/2. The second part says, using correct units, interpret the meaning of h prime of 6 in the context of the problem. So this is the woo-woo statement. We know this is a tough point to get. Think about if you remember what woo-woo stands for. It is what with units and when with units. So we know the when, so we're going to start with that. At time t equals, and that would be 6. So that is our when. The units of time is in years. We can see that in the chart. We can also see that right here. Time is measured in years. So at time t equals 6 years, and then that takes care of the units of when. So we have when with units, and we need what with units. So the last thing we need to do is just think about, if the h function is the height, right? The height of the tree is the function h, and we wrote it here as well. If h is the height of the tree, you want to think about, what would h prime represent, right? H is the height, and then the derivative, h prime, what would that represent? So that is going to be the rate of change of the height, or how the height is changing. So we're going to say at time t equals 6 years, the height of the tree is, and instead of saying changing, I'm going to use the word increasing or decreasing, because that word represents change. And my rate of change estimate was 5/2. So the height of the tree is going to be increasing. This word is crucial, because that is the word that is indicating the prime, right? The rate of change. That's what makes it h prime. The h function is just the height. H prime is how is the height changing. So that word increasing is the word that is demonstrating that the height is changing. So the height of the tree is increasing by 5/2. I'm going to scroll back up, because we have our when, we have our what, and we just need our units now. That's going to be the last thing, is the units of what. So the what is the height of the tree is increasing by 5/2, And the last part is our units. So there's two things you can do. The first thing that I was really liking was this diagram. And we were talking about how every time you take a derivative, you divide by a unit. So I'm just scrolling up to look that the height was in meters. So the h function, the height, is in meters. And so if you remember that diagram and remember us saying when you take the derivative, you're going to divide by a unit, that might indicate what the unit is to you, and you might know it already. The second thing that you could do is when you look at your 11 and 6 and 7 and 5, when you are subtracting, you could also write the units in to that quotient. So 11 and 6 was in meters, so you could write meters on the top, and the 7 and the 5 was in years, and you can write years on the bottom. So the units would be meters per year. And if you were using this diagram at the bottom, and remember we said when you take the derivative, you're dividing by a unit, so it'd be meters per year. You just have to know what is that unit you're dividing by. So it would be years because that's what time is measured in. So going back to our statement, at time t equals 6 years, the height of the tree is increasing by 5/2 meters per year. You could also write it as meters per year, something like that. So let's look at the rubric for this. The first point, as I said, was the estimate. If you can get 5/2, you've got that point. The second point, again, is that challenging interpretation, needing the woo-woo statement and all the pieces of that woo-woo statement in order to get that point. H prime of 6 is the rate at which the height of the tree is changing in meters per year at time t equals 6 years. It's a little bit different from our sentence because we said the height of the tree is increasing, but it would be fine. I'm just going to go back and look at ours again. The height of the tree is increasing by, yeah, so either one of those would be great, and that is it for part A.